Hi everyone. In this video we are going to look at the basic concepts that are related to access control, and then we are going to look at two main methods or two main ways of controlling the access or controlling the authentication, that is 802.1x authentication and MAC address authentication. So first let's take a look at just a couple of slides. As you might already be aware that whenever users or whenever any terminal wants to access the infrastructure, access the network, it first needs to be authenticated. This is what we call the identity authentication. And if the user is not authenticated, then the user is not allowed to access the network. However, if the user is authenticated successfully, then access is allowed and the user can access the network resources. But still, we need to implement certain authorization rules so that not all users can access all resources, and the user can only access the resources which they are allowed to access. And the users cannot access the resources which they are prohibited or which they are not allowed to access. And once they are accessing those resources, then we need to keep a check or keep an account of what they have been doing for accounting purposes. This is what we call the AAA model, or authentication, authorization, and accounting. In this module, we are going to take a detailed look at the authentication. But before that, let's take just a brief look at what we understand or what we mean by authorization. Because authentication we're going to cover in a lot of detail, but we'll take a brief look at what authorization is. The authorization rules that we configure on our devices or on our network controllers, they consist of two parts. One part is called the policy dimension and the other one is called the policy element. These two components together make up an authorization rule. By policy dimension, we mean the characteristics of the person on which or on whom we want to apply the policy. And the policy elements are the tools or techniques that we have at our disposal, according to which we can control the access of those users. So the user name or the terminal that is being used by the user, or the access mode, location, time, these are the different policy dimensions or the characteristics of the access which is happening in our network. And based on these characteristics, we can use any of these tools to control the access or to limit or to allow the access of those users to different resources. This concept is going to be helpful to us when we do the configuration later on the Agile controller for the authorization, or when we are configuring the authorization rules on the Agile controller. You'll see that we'll be doing the configuration for both these components, that is policy dimension and policy element. But we'll leave that for later. But right now, let's take a look at the two major methods of doing the authentication, that is 802.1x authentication and the MAC address authentication. So first we'll take a look at the 802.1x authentication, and then we'll look at MAC authentication basic concept, and then we'll move over to the configuration of 802.1x and MAC authentication. Okay, the 802.1x authentication concept was initially developed or was initially explored for wireless LANs or WLANs. However, nowadays it is being used for wireless as well as for different types of wired connections, for example Ethernet or PGP connections. So 802.1x is the authentication mechanism for any of these link layer protocols. 802.1x is dependent upon the authentication protocol that we call EAP, or Extensible Authentication Protocol, and we can use any of the types of EAP in using 802.1x, for example EAP MD5, EAP TLS, TTLS, etc. These are all different types of EAP authentication which can be used. The typical 802.1x authentication scenario involves a terminal, an access control device, and a radius server. What this means is, the concept is fairly simple, that whenever a terminal tries to access a network through an access device or an access control device, the access control device stops the user access consults the Radius server for authentication, and if the Radius server allows the authentication, or if this authentication is successful and the Radius server allows the access control device to let the terminal or let the user into the network, only then this control device or this access control devices allow the access of the terminal or the user to the network. So this is a 3-device combination, or this entire mechanism revolves around these 3 types of devices: the terminal device, the access control device, and the Radius server device, which is actually responsible for making the authentication possible. When we are configuring the authentication, there are different concepts related to it, 2.1x authentication. We can have different authentication methods, we can have different authentication modes, and we can have different port control modes. For example, the authentication methods that we can use can include the port-based authentication or the MAC address-based authentication. For example, in port-based authentication, if one user has been authenticated through any port, then all other users who are accessing the network through the same port will automatically be authenticated, and they will be allowed to access the network, because we are authenticating a port, not individual users. However, as you can see, this might lead to insecure access or rather unsecure access for the users. Therefore, we can also have MAC address-based authentication, which means that even though different users are accessing or are trying to enter the network through the same port, however, each user has to be authenticated separately, and any successful authentication is only for a specific MAC address, and other MAC addresses will have to be authenticated separately. Similarly, authentication mode can either be EAP termination or EAP relay. In case of EAP termination, the authenticating device, that is the access switch or the switch on which the users are through which the users are accessing the network, that device terminates the 802.1x authentication request, carries it in Radius, or sends it to the Agile controller or the Radius server through a Radius message. However, in case of EAP relay, the EAP request or the authentication request, username, password, etc. are not passed by the intermediate device or by the authenticating device. However, it is sent directly to the Agile controller, and the Agile controller directly takes care of or handles this authentication request. If you look at the port control mode, there can be different port control modes that we can use. We can have automatic identification, which means that initially a port on the switch, for example, a port on the switch is in the unauthorized state, but as soon as, which means it is not allowing any traffic to pass through, but as soon as the user is authenticated, then it transitions into the authorized state, and then the user's traffic can be sent and received through that port. Forcible authorization means that a port will always be in the authorized state and all traffic can move through the port. Forcible non-authorization means that the port is in unauthorized state always and no traffic is allowed to pass through the port. So these are the different concepts which are associated with 802.1x authentication, and we might need to use any of these options while we are doing the configuration based on our specific requirements. You already know the basic flow or the basic authentication process. However, in this slide, in this picture, we'll take a little bit more detailed look on the authentication process. Here is the client or the terminal or the user, we can say. Here is the access control device, and here is the Radius server. This client needs to have the 802.1x client software running on it. It sends in extensible authentication protocol over LAN or ePOL start message. The start message is received by the control device. It sends a request identity message back, and in response to this identity message, we receive an identity response message. This message is converted into Radius message, or it is sent directly as the EAP message to the Radius server, depending on what termination mode we are using on this control device. It is sent to the Radius server. The Radius server sends an MD5 challenge, and this challenge is forwarded to the client. The client sends a challenge response, and if this response is acceptable to the server, the authentication is successful, and the authentication success message is sent to the client, and now the client can access the network through this control device. So this is just a brief overview of the entire 802.1x authentication process and how this authentication takes place. If you look at the MAC authentication process, the MAC authentication takes place when the terminal device is a dumb terminal, which means it's either a printer or an IP phone which does not have an 802.1x client software installed on it. It does not support that software, or we do not want the client to be authenticated, even though it's not a dumb device, it's an intelligent device. However, we do not want the user to enter username and password, and we want the user to be directly authenticated using the MAC address. In that case, we can have the MAC authentication available, or we can make use of the MAC authentication. Otherwise, once we understand this concept, the rest of the flow and the concept is very similar. The request is intercepted by the device, and this device sends the MAC address of these devices as the username password to the radius server. The radius server checks the MAC address, and if the MAC address is allowed through configuration and we have allowed that MAC address to access the network, it sends a go ahead or a success, authentication success message, and then this access device is going to allow the device's traffic to enter the network. This is a typical scenario where we have either the dumb devices which do not support 802.1x authentication, or we can even have intelligent terminal devices which do not want to be authenticated using 802.1x. They can either be wired connections or they can be wireless connections. So this means that we can have either 802.1x wired authentication, or we can have 802.1x wireless authentication. Similarly, we can have MAC address wired authentication or wireless MAC authentication, depending upon our specific implementation and requirements. And this is the detailed authentication process for MAC address authentication. We have we set up a pre-connection, then using that connection we send, or the terminal sends the DHCP or neighbor discovery IPv6 neighbor discovery messages, or DHCP v6 messages. These messages are passed on to the radius server, and if the MAC address is already configured and allowed on the radius server, then the successful authentication happens, or authentication is successful, and the traffic will be allowed into the network, and this user will now show as logged in or connected user on the radius server or on the access control device. However, if the device sends a deregistration request, we can also deregister the device, and it will stop showing as connected device either on the radius server or on our access control device. So let's take, in the next video, let's take a look at the configuration of 802.1x authentication and MAC address authentication, and then we'll be able to better understand the entire process. See you in the next video.